Hi, good day everyone. Today we are going to learn radioactive decay in 15 minutes. Firstly, we are going to look at the learning outcome. The learning outcome stated that at the end of this lesson, you are able to explain with examples decay equations for alpha decay, beta decay, and gamma decay. But what does this mean? Suppose we have a radioactive decay equation like uranium-238. When it undergoes alpha decay, what will happen? How about carbon-14? How to complete these beta decay equations? As for gamma decay, what will thorium-234 be? How we make both sides of all the radioactive decay equations to be inequivalent to each other's. In order to find out the answer, we are going to do a quick recap first. In the center of every atom is a nucleus which contains protons and neutrons. The proton is positively charged, positive one, while the neutron is neutral. Both of them have relative mass of 1. Then, opening around the nucleus in the shell is electron. Electron is negatively charged, negative 1, and it is about 2000 times smaller than protons or neutron. If you look at the periodic table, each box is known as a particular chemical element, like this one for lithium. Inside the box is all the important information about the element. In the middle, we have element symbol, so Li stands for lithium. At the bottom, we have the atomic number, which is the number of protons. This is really important for us because the number of protons can determine which element it is. On the top, we have the mass number, which tells us the total number of protons and neutrons together. So, the mass number of lithium is 7 because it has 3 protons and 4 neutrons. Now, you might be realizing that the chemical element doesn't directly tell you the number of electrons, but you just have to remember this. The number of protons and electrons in an atom is the same. This is why the number of electrons is 3 in this case. Now, we will proceed with the introductions. Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiations. This process is random and spontaneous because it is not influenced by temperature, pressure, and other physical factors. There are 3 types of radioactive radiations, such as alpha particle, beta particle, and gamma ray. We normally represent alpha particle with helium, beta particle with electrons, and gamma ray with just gamma. Next up, we will look at alpha decay first. When alpha decay happens, unstable parent nucleus will emit alpha particle to become a stable daughter nucleus. According to this alpha decay process, we have a general equation for it. Now, let's take a look at the example. When an unstable nucleus like uranium-238 undergoes alpha decay, it emits alpha particle, which means it loses 2 protons and 2 neutrons. To show you this, we have to subtract 4 from the mass number and 2 from the atomic number. As a result, we will get an element with mass number of 234 and atomic number of 90. Because the atomic number has changed, the chemical element will change as well. By referring to the periodic table, we found out it is now thorium instead of uranium, as you can see from here. Alright, how about beta decay? When beta decay happens, unstable parent nucleus will emit beta particle to become a stable daughter nucleus. Beta decay is actually a bit more complicated because it involves a neutron turning into a proton and emitting a fast-moving electron, which represents the beta particle. According to this beta decay process, we have a general equation for it. So now, let's take a look at the example together. When an unstable nucleus like carbon-14 undergoes beta decay, it emits one beta particle, which is the electron. Because it is effectively gain a proton, its atomic number will increase from 6 to 7, making a nitrogen rather than carbon. However, you will realize that the mass number will actually stay the same, which is 14, because although it gained a proton, it also lost a neutron. Alright, the last decay process, gamma decay. When gamma decay happens, unstable radioactive nucleus in an unexcited state release its excess energy, which is gamma ray, to become a stable nucleus with less energy. According to this gamma decay process, we have a general equation for it. Now, let's continue with one example. When an unstable nucleus like thorium-234 undergoes gamma decay, it emits gamma ray to form thorium-234 again. Why is that so? Because gamma radiation is pure energy, so it doesn't change anything. That is why 234 thorium is maintained even after gamma decay process. Moving on, we have an additional condition. During a radioactive decay, some nuclei can emit more than one radiation. For example, during the decay process, uranium-234 emits alpha particle and gamma ray to form thorium-2,3-O. A simpler decay equation will be as follows. Okay, now we are closer to the end of the lesson. Let us summarize the content that we have learned together. First, unstable nucleus becomes more stable by emitting radioactive radiations. There are three types of radioactive decay equations, such as alpha decay, beta decay, and gamma decay. Okay, before I end the class today, let's do one question, only one, to test your understandings. The question stated that the decay series of a radioactive source is shown in the equation below. As you can see, uranium-238, after undergo a decay process, becomes lead-214. So now we are asked to determine the total number of alpha and beta particles that are emitted from this decay process. Okay, I will now give you a few minutes to attempt these questions. Good luck! 3, 2, 1. Alright, I will review the solutions now. As you are solving a simultaneous equations of two unknowns, you need to first make an assumption like this. Let there be X alpha and Y beta particles be emitted. This is the first step you must do. Second step, you need to write down the simultaneous equations that you are going to solve based on the information that are given in the questions. The third step, you need to equate the atomic number and the mass number that you get. Alright, so now 92 equals to 82 plus 2x minus y. And simplification of these first equations will give you 2x minus y equal to 10. On the other hand, 238 equal to 214 plus 4x. This is the second equations. And the simplifications of these second equations will give you x equal to 6. By using substitutions, substitute x equal to 6 into 2x minus y equal to 10. And simplification will then give you y equal to 2. Okay, now this is actually a quite important step, which is the last step. You may check your answer by substituting both values into either one of these simultaneous equations, the original equations. Okay, so now we know that there are a total number of 6 alpha particles and 2 beta particles that are emitted. Alright, I think this is the end of our class. Thanks for watching. Bye. See you.